Welcome to my YouTube channel. Please don't forget to subscribe, like, and share.
Welcome to my architecture review note series on building utilities. Our topic for this video is to gain knowledge and insight into the various types of valves used in plumbing, sanitary and piping systems, including their structure and function, the mechanism behind how they control water flow, where they're used, their role in regulating, directing, or stopping water or gas flow, and how they differ.
What are valves? Valves are mechanical devices used to control the flow and pressure of liquids or gases within a system. They do this by opening, closing, or partially obstructing passageways. Depending on the design, valves can start or stop flow, regulate pressure or flow rate, prevent backflow, and direct flow. Valves are essential components found throughout plumbing and sanitary systems, including water supply, distribution lines, drainage systems, and heating networks. Proper selection of valves in building systems is crucial to ensure safety, operational efficiency, and the longevity of the entire plumbing or mechanical setup.
Valves are classified according to function to clearly define what role they perform within a piping or plumbing system. Each functional category, such as isolation, control, non-return, pressure-reducing, or safety, is designed to address a specific operational need, like stopping flow, regulating pressure, preventing backflow, or releasing excess pressure. Isolation valves are valves used to completely stop or allow the flow of fluid in a plumbing or piping system. Their main function is to isolate a section of the system for maintenance, repair, or emergency shutdown without affecting the rest of the system. Common types include gate valves, ball valves, and butterfly valves, which can be quickly opened or closed. The mechanism varies depending on the type, but they all operate to either fully open or fully close the passage of fluid.
A gate valve operates through a sliding gate or wedge mechanism that moves up or down perpendicular to the flow to start or stop fluid. Its primary function is for on and off control, not throttling. Gate valves are suited for large diameter pipelines and offer less pressure drop when fully open. Advantages include low flow resistance and tight sealing, especially for straight line flow. However, it has slow operation, is not ideal for throttling, and can jam if sediment builds up. Gate valves are commonly used in water supply systems, wastewater lines, and industrial applications where the valve remains either fully open or fully closed for long periods. A rising stem gate valve uses a threaded stem that visibly rises as the valve opens, making it easy to see whether the valve is open or closed. Its mechanism involves turning the handwheel to lift the gate vertically, allowing or stopping flow. A non-rising stem gate valve operates by turning the stem inside the valve body without the stem moving up externally. Its mechanism involves a threaded stem that rotates in place, lifting or lowering the gate internally to control flow. A solid wedge gate valve uses a single, rigid wedge-shaped gate that moves up and down to block or allow flow. Its mechanism provides a tight seal, but it can become stuck or damaged in systems with thermal expansion or pipe misalignment. In contrast, a flexible wedge gate valve has a cut or groove in the wedge, allowing slight flexing to absorb thermal stress and maintain sealing even with minor pipe distortion. Both are used for on or off isolation, but the flexible wedge performs better in high temperature or variable pressure systems. The solid wedge is advantageous for simple, low-pressure systems, while the flexible wedge is preferred in steam lines, hot water systems, or areas with potential misalignment. Disadvantages include slower operation and vulnerability to debris. A parallel slide gate valve uses two parallel discs that slide between the seats, with a spring or wedge mechanism pushing them apart to ensure sealing. Unlike traditional wedge gate valves, there is no wedging action, reducing friction during operation. Its function is to provide tight shutoff in on or off service, especially in high-temperature steam systems, as it allows thermal expansion without jamming. This valve is better for frequent cycling and systems prone to thermal stress, though it is bulkier and requires more space. A solid slab gate valve operates with a single solid gate that moves vertically between two seats to control fluid flow. Its mechanism offers a simple up and down movement with full bore opening, minimizing pressure drop. The function is for on-off control in pipeline systems, especially where pigging is required. It provides unobstructed flow but lacks the same tight shutoff in low-pressure systems. A brass gate valve uses a wedge-shaped gate that moves vertically to start or stop the flow of liquid. Its mechanism is designed for full open or full close operation, not for throttling. The function is to isolate flow in plumbing systems, especially for potable water, where brass resists corrosion and is lead-free when required. Brass gate valves are cheaper and better for low-pressure or residential applications. A knife gate valve operates using a thin, sharp-edged blade that moves vertically to cut through and isolate the flow of slurries, viscous fluids, or solids-laden liquids. Its mechanism is ideal for on or off control, especially in wastewater, mining, and pulp applications.
Another type of isolation valve is a ball valve. A ball valve rotates to open or close quickly. It uses a rotating ball with a hole or bore through its center. When aligned with the pipe, flow occurs. When turned 90 degrees, the solid part of the ball blocks flow. A ball valve provides quick shutoff with a tight seal and is ideal for applications needing reliable on or off control. It is not ideal for throttling or partially open flow control, as the ball design can cause turbulence, erosion, or inaccurate control. Its typical uses are for fixture shutoffs such as under sinks or toilets, gas lines, water supply lines, and HVAC systems. The most common ball valve design is the floating type. A floating ball valve has a ball that is not fixed to the stem or body, allowing it to float slightly and press against the downstream seat to create a tight seal when closed. Its mechanism relies on line pressure to aid sealing, making it effective for bidirectional shutoff. A trunnion ball valve features a ball supported by trunnions or fixed shafts at the top and bottom, preventing it from moving under pressure. Unlike floating ball valves, its mechanism ensures the ball stays fixed while seats move toward the ball to create a seal. A mini ball valve operates using the same mechanism as standard ball valves, a rotating ball with a bore that opens or closes flow with a 90 degrees turn, but is designed in a compact, lightweight form. A full-port ball valve has a ball with a bore equal to the pipe's inner diameter, allowing unrestricted flow with no pressure drop. Its mechanism involves a 90 degrees rotation of the ball for simple on or off control. A reduced port ball valve, also known as a standard port valve, has a ball with a smaller bore than the pipe diameter, causing a slight restriction in flow. Its mechanism works like other ball valves, rotating the ball 90 degrees for on or off control, but with reduced flow efficiency. A three-way ball valve has 3 ports and a ball with an L-shaped or T-shaped bore that rotates to divert, mix, or split flow between different lines. Its mechanism enables flow routing in multiple directions, unlike standard two-way valves that only allow open or closed flow. The main function is to control multiple flow paths with a single valve. A one-piece ball valve is made from a single solid body with the ball sealed inside. The ball rotates 90 degrees to open or close flow. The one-piece ball valve provides simple on or off control with a compact design. It is the cheapest type of ball valve and is compact and lightweight. It has fewer leak points due to one-piece body. However, it is non-serviceable or cannot open for cleaning or repair. It is limited to small-size, low-pressure systems. A two-piece ball valve consists of 2 separate body parts screwed or bolted together, enclosing the ball inside. Its mechanism allows the ball to rotate 90 degrees to control flow, just like other ball valves. It provides reliable on or off control with minimal pressure drop, similar to full port designs. Compared to a one-piece valve, it can be partially disassembled, allowing limited access for maintenance or cleaning. A three-piece ball valve has a central body that holds the ball and two removable end caps, allowing it to be disassembled without removing the valve from the pipeline. Its mechanism involves a ball with a bore that rotates 90 degrees to control flow. The function is to provide tight on-off flow control while allowing easy maintenance.
The next type of isolation valve is a butterfly valve. A butterfly valve uses a rotating disc mounted on a central shaft as its mechanism to control flow. When turned 90 degrees, the disc aligns with or blocks the flow, providing quick shut-off or regulation. Its main function is to start, stop, or throttle flow efficiently in large systems. The key advantages are its compact size, lightweight design, and lower cost, especially for large-diameter pipes. However, it offers less tight sealing and may cause pressure drop when partially open. It is commonly used in HVAC systems, water distribution, fire protection, and wastewater treatment, where space saving and cost efficiency are priorities over perfect sealing. A wafer butterfly valve has a disc mounted on a central shaft that rotates to open or close flow, held in place between flanges using long bolts that pass through the valve body. Its mechanism allows for 90 degrees disc rotation to provide shut-off or throttling. The main function is to control flow in a compact, lightweight form. A lug butterfly valve features a disc mounted on a central shaft and a lug-style body with threaded inserts that allow it to be bolted directly between flanges on both sides without needing nuts. Its mechanism enables the disc to rotate 90 degrees for on-off or throttling control. A flanged butterfly valve uses a rotating disc on a central shaft to control flow and features flanged ends that are bolted directly to the pipe flanges for a secure, leak-resistant connection. Its mechanism allows 90 degrees rotation for quick on, off or throttling control.
A plug valve uses a rotating cylindrical or tapered plug with a through hole to control fluid flow. When the plug is turned, the hole aligns or misaligns with the pipe, allowing or blocking flow. Its function is for quick shutoff and it offers faster actuation with a simple 90-degree rotation. Plug valves often have a smaller footprint and can handle slurries and corrosive fluids with proper lining. The advantages include compact design, minimal pressure drop, and ease of operation, while disadvantages involve high torque requirements, potential wear on sealing surfaces, and difficulty in maintenance. Typical uses are in chemical processing, oil and gas, and water treatment systems where tight shutoff and reliable sealing are critical. An angle valve works through a stem-operated mechanism that opens or closes a seat positioned at a 90-degree angle, allowing flow to change direction within the valve body. Its function is to control or shut off fluid flow while enabling a right-angle turn in the piping system. Compared to other valves like globe or gate valves, angle valves are more compact, making them ideal for tight spaces. Their advantages include space efficiency, moderate flow control, and ease of installation in corner pipe runs. However, they can cause a higher pressure drop than straight-through valves and are not ideal for high-flow or slurry applications. Typical uses include residential water supply lines, toilet and faucet shutoffs, and HVAC systems, where directional change and control are needed in a compact design. A pinch valve operates using a flexible rubber or elastomer sleeve that is pinched or compressed by a mechanism, air or mechanical, to stop or regulate flow. Its function is to control the flow of fluids, especially those with solids or abrasive particles, by squeezing the sleeve shut without direct contact with valve components. Unlike other valves, pinch valves have no internal obstructions, making them ideal for slurries, powders, and corrosive fluids. The advantages include low maintenance, minimal wear, and full bore flow when open. The main disadvantages are limited pressure and temperature resistance and sleeve replacement over time. They are typically used in wastewater treatment, mining, pulp and paper, and chemical processing, where cleanliness and media isolation are critical. A piston valve operates through a cylindrical piston that moves vertically inside a valve body to control flow by covering or uncovering ports. Its function is to regulate or shut off fluid flow, offering a tight seal through metal to metal or soft seating with rings around the piston. Compared to other valves like globe or gate valves, it provides better sealing, especially in steam and high-pressure applications. Its advantages include leak-tight performance, low maintenance, and long service life due to reduced seat wear. However, its disadvantages are higher cost and more complex design, which may not be suitable for all systems. It is commonly used in steam lines, chemical plants, and refineries where leak prevention and durability are critical.
Control valves are mechanical devices used to regulate the flow, pressure, temperature, or level of fluids, liquids, gases, or steam in a piping system. They automatically adjust the size of the flow passage based on a signal from a controller, usually as part of a larger process control system. The mechanism typically involves an actuator, electric, pneumatic, or hydraulic that moves a valve plug, disc, or ball to throttle or modulate the flow rather than just opening or closing it fully, as in isolation valves. Functionally, control valves maintain process variables, like flow rate or pressure, at desired levels by continuously adjusting to meet changing system conditions.
One of the common type of control valves is a globe valve. A globe valve operates using a linear motion disc that moves perpendicular to the seat, effectively regulating or throttling flow. Its function is to control flow rate or shut off flow with precision, making it ideal where flow regulation is required. The advantages of globe valves include excellent throttling capability, tight shut-off, and good flow control accuracy. However, they have higher pressure drop, slower operation, and are less compact. They are typically used in water systems, fuel oil systems, and high-pressure steam lines where precise flow control is necessary. The Z-type or T-type is the most common design of globe valves. A Z-type globe valve features a Z-shaped body where the flow changes direction twice, causing a high pressure drop but allowing precise throttling. Its mechanism uses a movable disc pressing against a stationary seat to control or stop flow. Common brass globe valves are typically Z-type globe valves. A Y-type globe valve has a diagonal body design, positioning the stem and seat at an angle, which allows for smoother flow and lower pressure drop compared to a Z-type globe valve. Its mechanism involves a disc moving perpendicularly onto the seat to throttle or shut off flow. An angle-type globe valve features a 90-degree turn in the flow path, where the disc moves vertically to the seat to control or stop fluid flow. Its mechanism allows flow to change direction within the valve, eliminating the need for an extra elbow in piping.
A diaphragm valve uses a flexible diaphragm that presses down onto a seat to control or stop fluid flow, separating the working parts from the process media. Its mechanism allows for precise throttling or shut off, and its function is ideal for handling corrosive, abrasive, or sanitary fluids. Advantages include excellent chemical resistance, easy cleaning, and leak-tight sealing. Its disadvantages are limited pressure and temperature range and not suitable for high-pressure applications. It is commonly used in pharmaceutical, food, water treatment, and chemical processing systems, where clean operation and media isolation are critical. A needle valve uses a slender, tapered point, needle, that moves precisely into a matching seat to regulate flow with fine control, especially in low-flow systems. Its mechanism allows gradual and accurate flow adjustment, making it ideal for metering small volumes of gases or liquids. Unlike other valves which are designed for quick on-off control, needle valves provide precise throttling. Advantages include accurate flow regulation, leak-tight shutoff, and durability in high-pressure applications. However, its disadvantages are slower operation, limited to low flow rates, and higher cost than basic shutoff valves. It is typically used in instrumentation lines, fuel flow control, and hydraulic systems where precision is critical. A flow control valve regulates the rate of fluid flow in a system by adjusting the orifice size through which the fluid passes. Its mechanism involves a movable part, such as a sliding spool or needle, that changes the cross-sectional area to control speed and pressure. The main function is to maintain a desired flow rate regardless of load variations. Advantages include precise flow regulation, improved system efficiency, and protection of downstream equipment. Disadvantages are its complexity, higher cost, and potential for clogging in dirty systems. It is commonly used in hydraulics, irrigation systems, and pneumatic circuits where flow rate consistency is essential. A shower mixer control valve blends hot and cold water to deliver water at a consistent desired temperature. Its mechanism typically involves a cartridge, thermostatic element, or pressure balancing spool that adjusts the mix based on user input or fluctuations in pressure or temperature. The primary function is to provide safe and comfortable water temperature for showers. Its advantages include user comfort, burn protection, and easy adjustment. However, disadvantages are higher cost, maintenance needs, and sensitivity to water pressure changes. It is commonly used in residential and hotel showers for temperature control and safety.
Another classification of valves by function are non-return valves. A non-return valve is a type of valve that allows fluid to flow in only one direction and prevents backflow, protecting equipment and maintaining system integrity. It operates automatically, opening when fluid flows in the correct direction and closing when flow reverses. Non-return valves are designed to protect the system from reverse flow, and so they fall under the broader category of protective valves.
Check valves are one-way valves that allow fluid to flow in only one direction and automatically prevent backflow. They operate based on differential pressure. Flow in the correct direction pushes the valve open, while reverse flow forces it closed. The basic mechanism involves a disc, ball, or flap that moves freely to open with forward flow and seals shut with reverse flow. They do not require a handle or actuator and operate automatically. The main function of a check valve is to protect pumps, compressors, and piping systems from damage caused by backflow. They also help maintain system pressure and prevent contamination in mixed fluid systems. Advantages include simple operation, no external power, and low maintenance, while disadvantages include the potential for water hammer, wear over time, and limited control over closing speed. They are widely used in water supply lines, sewage systems, fire protection, HVAC, and industrial process systems, where backflow prevention is essential. A swing check valve uses a hinged disc that swings open with forward flow and closes automatically when flow reverses, preventing backflow. Its mechanism relies on gravity and flow pressure rather than manual or powered actuation. The main function is to allow one-way flow and protect equipment like pumps and compressors from reverse flow damage. A ball check valve operates using a free-floating ball that moves in response to flow. When fluid flows forward, the ball lifts off its seat to allow passage. When flow reverses, the ball returns to the seat, blocking backflow. Its function is to act as a non-return valve, allowing flow in only one direction. A lift check valve uses a disc that moves vertically within a guide to open or close based on flow direction. When fluid flows forward with enough pressure, the disc lifts off its seat. If flow reverses, gravity or back pressure forces the disc down, sealing the valve to prevent backflow. Its function is similar to other check valves but is best suited for high-pressure systems. A diaphragm check valve uses a flexible rubber or elastomeric diaphragm that flexes open to allow forward flow and automatically closes when flow stops or reverses, preventing backflow. Its function is to allow one-way flow without requiring springs or metal parts. A dual-plate wafer check valve operates using two spring-loaded plates, or discs, that pivot on a central hinge pin and open with forward flow, then quickly snap shut to prevent backflow when flow stops or reverses. Its function is to provide non-return flow control with minimal pressure drop. This valve automatically closes and is used solely for backflow prevention. A spring-loaded check valve uses a spring mechanism to hold the valve closed until the inlet pressure exceeds the spring force, allowing fluid to flow in one direction. Its function is to provide automatic backflow prevention with a quick closing response. A foot valve is a type of check valve installed at the bottom of a pump suction line, typically submerged in water. Its mechanism includes a spring-loaded or weighted disc that opens under suction and closes to prevent backflow when the pump stops. The function is to maintain pump priming by stopping water from draining out of the suction line. Its advantages are prevention of pump damage, improved efficiency, and protection against debris when equipped with a screen. The disadvantages include possible clogging, wear from sediments, and maintenance difficulty if submerged. It is typically used in well pumping systems, irrigation, and water intake lines. A backwater valve is a type of check valve designed to prevent reverse flow of sewage or stormwater into buildings, especially during heavy rains or sewer backups. Its mechanism involves a flap or gate that remains open under normal flow and closes automatically when flow reverses. The function is to protect basements and lower floors from flooding due to sewer backup. Its advantages include flood protection, automatic operation, and simple design. However, its disadvantages are potential clogging, regular maintenance, and limited use to low-pressure systems. It is commonly used in residential drainage, basement plumbing, and stormwater systems.
Pressure-reducing valves, PRVs, are automatic control valves designed to reduce and regulate the pressure of a fluid, usually water, steam, or gas, from a higher inlet pressure to a lower, stable outlet pressure. The mechanism typically involves a spring-loaded diaphragm or piston that adjusts the valve opening based on downstream pressure. Their main function is to protect plumbing systems and equipment from high pressure that could cause damage or leaks. PRVs maintain consistent outlet pressure regardless of fluctuations at the inlet.
A water pressure reducing valve operates through a spring-loaded diaphragm mechanism that automatically reduces high inlet pressure to a controlled, lower outlet pressure. Its primary function is to protect plumbing systems and fixtures by maintaining a consistent downstream pressure, regardless of upstream fluctuations. Unlike other valves that simply allow or stop flow, this valve modulates pressure continuously. Its advantages include preventing pipe bursts, reducing water waste, and extending appliance life. However, it may cause pressure drops, require regular maintenance, and can become noisy if debris clogs the seat. It is typically used in residential, commercial, and irrigation systems to ensure safe and efficient water delivery, differing from other valves by its focus on regulating pressure, not just flow. A direct-acting water pressure-reducing valve uses a spring-loaded diaphragm or piston that reacts directly to downstream pressure changes to reduce and maintain a lower outlet pressure. Its mechanism is compact and self-contained, requiring no external pilot. The function is to provide immediate pressure control in low to moderate pressure systems without relying on complex controls. A pilot-operated water pressure-reducing valve uses a main valve and a smaller pilot valve to control downstream pressure more accurately. The mechanism works by using the pilot valve to sense outlet pressure and adjust the main valve accordingly through a diaphragm or piston chamber, allowing smoother, more stable regulation. Its function is to maintain a constant outlet pressure even during high flow or fluctuating inlet conditions. A safety valve for vapor, gas service is designed to automatically release pressure when it exceeds a preset limit, protecting equipment from overpressure. Its mechanism involves a spring-loaded disc that lifts when the internal pressure surpasses the set point, allowing vapor or gas to vent rapidly until normal conditions return. The function is to provide emergency pressure relief in systems handling compressible fluids like steam or air. Its advantages include quick response, high reliability, and fail-safe operation, while its disadvantages include noise, inability to reseat without pressure drop, and potential loss of valuable gas. It is typically used in boilers, pressure vessels, and gas pipelines, differing from other valves by being fully automatic, pressure-activated, and designed specifically for vapor or gas rather than liquid service. A relief valve is a pressure control valve designed to protect liquid systems from overpressure by opening gradually when the pressure exceeds a set limit. Its mechanism relies on a spring-loaded disc or piston that lifts in proportion to excess pressure, allowing fluid to escape and thus regulating system pressure. The main function is to relieve pressure in hydraulic or liquid systems to prevent equipment failure. Its advantages include smooth pressure modulation and suitability for liquid applications. However, a disadvantage is that it's not ideal for vapor or gas systems, where sudden pressure spikes require quick discharge. Typical uses include pumps, pipelines, and hydraulic circuits. Unlike safety valves used for gas, relief valves do not pop open but respond proportionally, making them distinct from other pressure relief devices. A safety relief valve is a spring-loaded valve designed to automatically open fully when the system pressure exceeds a preset limit and close once normal pressure is restored, protecting equipment from overpressure conditions. Its function combines the features of both safety valves for gas or vapor and relief valves for liquid, making it suitable for mixed-phase systems. A pressure relief valve operates using a spring-loaded mechanism that allows the valve to open gradually as the liquid pressure exceeds a set limit, then closes when pressure normalizes, maintaining safe system conditions. Its function is to protect systems from excessive liquid pressure, typically in hydraulic or liquid-filled systems. A pressure vacuum relief valve, PVRV, uses either a spring-loaded or weight-loaded mechanism that allows it to open under excess internal pressure or external vacuum conditions. When the internal pressure rises above a set point, the valve relieves the pressure to prevent overpressurization. Conversely, when a vacuum forms inside the tank, such as during emptying or cooling, the valve opens to admit air, preventing structural collapse. This dual action distinguishes it from standard relief valves, which typically respond only to overpressure. A temperature and pressure, T&P, relief valve operates through a spring-loaded mechanism that opens when either pressure exceeds a set limit or temperature rises beyond safe levels, typically in water heaters or boilers. Its function is to prevent tank explosions by releasing hot water or steam when unsafe conditions occur.
Another classification of valves by function are special-purpose valves. Special-purpose valves are designed for specific functions or unique operating conditions that standard valves cannot adequately handle.
A float valve operates using a floating ball or arm that rises and falls with the liquid level in a tank or cistern. Its function is to automatically control the inflow of water, opening when the level is low and closing when the desired level is reached. Its key advantage is automatic operation without external power, making it simple, reliable, and low cost. However, it can be prone to wear or malfunction in dirty or high-pressure conditions, and may offer less precise control compared to electronically actuated valves. It is typically used in toilet tanks, water tanks, cooling towers, and cisterns, differing from other valves by its passive, level-dependent mechanism. A vacuum breaker is a type of special-purpose valve designed to prevent back siphonage by allowing air into the system when a vacuum or negative pressure occurs. Its mechanism uses a spring-loaded or gravity-operated valve that opens when internal pressure drops below atmospheric, admitting air to break the vacuum. The main function is to protect potable water supplies from contamination due to reverse flow, especially in fixtures like hose bibs, urinals, or irrigation systems. Its advantages include simplicity, low cost, and reliable backflow prevention in low-risk applications. However, its disadvantages include limited protection under continuous pressure and susceptibility to leaking or failure if not properly maintained. Typical uses are in residential plumbing, irrigation systems, and lab or industrial water lines where intermittent flow and potential back siphonage are concerns, distinguishing it from other valves by its automatic, air-admitting feature rather than fluid control. An anti-siphon vacuum breaker operates by allowing air to enter a plumbing or irrigation system when negative pressure or vacuum occurs, thereby breaking the siphon effect and preventing backflow of contaminated water into the potable supply. Its function is solely for backflow prevention, not flow regulation. The main advantage is its simple, passive operation. It activates automatically without manual intervention and offers critical protection against contamination. A disadvantage is that it must be installed above the highest downstream outlet, limiting placement flexibility, and it cannot handle continuous pressure unless designed as such. It is typically used on hose bibs, wall hydrants, toilets, or irrigation systems, especially where there is a risk of back siphonage. It differs from other valves in that it does not control flow but rather focuses solely on preventing reverse flow using atmospheric pressure. A multi-port plug valve uses a rotating cylindrical or tapered plug with multiple flow paths to control the direction and flow of fluid through more than 2 ports in a piping system. Its function is to divert, mix, or shut off flow between various ports, making it ideal for complex flow arrangements. The main advantage is its compact design, allowing quick operation and versatile flow control with a single valve body. However, its disadvantages include limited pressure capacity, potential for leakage over time, and higher maintenance in abrasive or dirty surfaces. It is typically used in chemical processing, water treatment, and industrial systems where flow direction must be changed frequently. Unlike other valves that handle simple on-off or throttling duties, this valve is designed for multi-directional flow control. A line-blind valve works by inserting a solid metal plate, blind, or a rotating disc between pipe flanges to completely block flow, providing a positive shutoff that is visually verifiable. Its function is to isolate a pipeline section for maintenance or safety without relying on valve seals that may leak. A major advantage is its absolute sealing capability, ensuring zero leakage, especially in hazardous fluid systems. However, it is manual, often heavy, and requires shutdown and labor to operate, making it less convenient than standard valves for frequent operation. It is commonly used in refineries, chemical plants, and pipelines carrying toxic or flammable materials where safety and full isolation are critical, distinguishing it from other valves that rely on internal seals.
In conclusion, each valve serves a specific purpose and comes with its own advantages and limitations. Choosing the right valve requires careful consideration of function, operating pressure, pipe size, and maintenance requirements. When properly selected and used, valves significantly contribute to the efficiency, safety, and longevity of any plumbing system.
Thanks for watching. Don't forget to subscribe, like, and share.
Enroll at Atlas CDC Review for a comprehensive prep for the Architecture Board exams. Message us now.